For most of cosmological history, the end of the universe looked quiet. Stars burning out one by one over trillions of years. Galaxies going dark. Black holes slowly evaporating into radiation. A long, cold, gradual fading stretching across timescales so vast they have no meaningful name. The heat death, the maximum entropy endpoint of a universe running down, was the accepted picture. Not dramatic, not violent, just an endless, deepening stillness spreading across everything that ever existed. In 2026, that picture started to change. The Dark Energy Spectroscopic Instrument, DESI, completed its largest survey yet, mapping the distribution and recession of tens of millions of galaxies across vast stretches of cosmic time. The data it produced is the most precise measurement of dark energy's behavior ever assembled. And what it showed was not what the standard model of cosmology predicted. Dark energy is not constant, it is changing, and it appears to be getting stronger. This matters enormously. For decades, the standard model has treated dark energy as a fixed property of space itself, a cosmological constant, the same value everywhere and at all times, a permanent and unchanging feature of the universe. If the DESI results hold under continued scrutiny, that assumption is wrong. Dark energy is dynamic. It evolves over cosmic time. And the direction it is evolving, toward higher values, toward increasing strength, leads somewhere far more violent than heat death. It leads to something called the Big Rip. Here is what that actually means. As dark energy strengthens, the expansion of space accelerates faster and faster without any limit. At first, the gravitational bonds holding galaxy clusters together are overcome. Clusters pull apart, their member galaxies drifting into isolation. Then individual galaxies dissolve, their stars separating as the space between them expands faster than gravity can counter. Then solar systems. The planets orbiting every star are pushed away as expansion reaches the scale of planetary orbits. Then the planets themselves, their internal structure overwhelmed as expansion penetrates to smaller and smaller scales simultaneously. Then atoms. In the final moments of the Big Rip, the expansion of space reaches the quantum scale. The strong nuclear force, the most powerful force in nature, the one that holds the nucleus of every atom together, is overpowered. Protons and neutrons are torn apart. Matter itself ceases to exist. Every particle in the universe is separated from every other particle by an expanding gulf that will never be crossed. The 2026 DESI data does not confirm the Big Rip is coming. The evolution of dark energy could plateau. It could reverse. The measurements carry uncertainties that future surveys will still need to resolve. But for the first time, the data gives the violent end a real statistical foundation. The quiet death is no longer the only scenario on the table. The universe may not go quietly after all.